Good morning to one and all. I am Parthivan, working as assistant professor in the Department of ECE. Now I am going to talk about the subject called Optical Communication and Networks, which is coming under the regulation R 2021. The subject code is CEC 345. It is meant for 5th semester ECE students. The core objectives are the Unit 1 deals about the various optical fibers, modes, configurations and its nature. The second unit deals with the transmission characteristics of optical fibers. Basically that deals with the attenuation, various losses and its effects and its characteristics. The Unit 3 deals about the optical sources and detectors as well as the transmission techniques. The various optical sources are primarily the LED and lasers. The various optical detectors are primarily APD as well as pin diode. In the fourth unit, we are going to deal about the various fiber optic measurements as well as various coupling techniques. The various optical measurements include the attenuation measurement, the numerical aperture measurement, the polarization measurement, etc. The Unit 5 deals about the various optical communication systems and the prevailing networks, how it has been configured, how the data has been transmitted and how the data has been received. In the outlet, I am going to talk about the introduction to optical fiber and its various structures and modes as well as about the advantages, disadvantages and applications also. Primarily, the OFC systems with its basic elements as well as its transmission techniques and types. There are basically two types of communications are involved. One is called wired communication, the other one is called wireless communication. Even in this modern era, we are going for wired communication. Why optical fiber communication? Because of its prevailing characteristics of very less attenuation as well as a very high bandwidth accommodation. That's why we are still using OFC for communication. The typical wired communication examples are coaxial cable, twisted pair cable as well as optical fiber cable. The wireless communication mode, we can have the mobile communication, satellite communication as well as DTH or we can say DBS, direct to home or digital broadcast services. Since optical fiber has been used very widely for continent to continent communication also, why it has been preferred? Because of its higher data rate, because of its longer coverage, because of its less attenuation, because of its compact nature, because of its least weight, because of its increased span of transmission, because of the high bitrate distance product. These are the prime features why we go for optical fiber. In the next one, we are going to see about the structure of optical fiber. The optical fiber consists of the primarily core, cladding as well as coating as well as jacket web. The core is made up of purely of glass. Then the cladding is nothing but the compound of glass material over which there is a strength membrane is there, over which there is a coating is there, over which there is an outer jacket is there. So these are primarily meant for to provide the mechanical strength to the optical fiber. Since it is made up of glass, we have to give the mechanical strength as much as possible to withstand all types of stress and strains. In the next, we are going to see about the basic structure. Actually, the core, cladding as well as the outer coating, these three forms the primary area coverage of optical fiber communication. The core index is called N1, that is refractive index of core is called N1. Then it is surrounded by the cladding, that is refractive index of N2. Generally, the core part is made up of pure solid dielectric cylinder. The cladding is over that which is covering one. Actually, the cladding reduces the scattering loss. The cladding provides the mechanical strength. Cladding provides from the surface contaminations also. Over which there is a buffer coating will also be there. That will give the elasticity, that will give the absorption resistant material, that will add further more strength to the optical fiber communication cable. The primary advantages of optical fiber communication is its low losses, immunity to crosstalk, then interference is very much less. Then light in weight, there is very small in size, more strength and highly secure and compact in nature, particularly meant for long distance communication as well as it is very easy and safe for installation purpose. So these are the prime reasons why we go for optical fiber communication till now. The primary disadvantages, we can say, the high or huge initial cost that is involved, as well as the maintenance and repairing cost of the optical fiber cable, as well as the joining and testing procedures are somewhat complicated. Actually, it has to withstand the tensile stress, as well as short links, as well as fiber losses. These features also we have to take into account before designing the OFs. Generally, the optical fiber communications are used for long distance communication, as well as for inter-exchange junctions, as well as for video transmission techniques, as well as for broadband services also. It is primarily used for computer data communication, as if like LAN, WAN, MAN, etc. It can also be used for military applications. It can also be used for non-communication applications like sensors and other readings. Measurements. The basic elements or primary elements of optical fiber communication lies here. Optical communication is one where we are converting the electrical signal into the optical signal. So here the electrical source is converted into light source, or we can say it's a modulation of light by means of light. We are transmitting the signals as light. We are receiving the signal as light, and after that we are decoding. It is primarily the electrical input signal is converted to the optical signal by means of a LED source or laser source. That's what we are doing in the transmitter side. Then the light source is propagated via an optical fiber cable, and it has been duly propagated through regenerative networks, and it has been duly received by means of optical receivers like APD or PIN diode. The photodetector detects the light, and the signal has been amplified, and the signal has been restored and decoded, and it is further again given as the original electrical signal, and it has been fed as the output. This is what the propagation of optical communication means. Then in the digital mode of optical fiber communication, we can say the signal is first of all encoded as a digital one. Then it is applied to a laser unit. Then the laser is propagated as a light. That laser is propagating the light by means of a fiber optic cable, and it has been duly received by the APD, that is avalanche photodiode. This receives the light as the light waves as the input, and it has been amplified and equalized, and it has been given to the decoder. So the decoder decodes the data, and it has again been converted into digital output. The original digital signal has been retrieved, and it has been given as the input signal. This is the digital nature of optical fiber communication transmission. Then coming on to the ray theory, the primary intent or the primary purpose of propagating the light waves depends on the concept called total internal reflection. It is basically depends on the Snell's law. What Snell's law states is N1 sin phi 1 is equal to N2 sin phi 2. N1 is the refractive index of primary medium, that is core 1. Then phi 1 is nothing but the incident angle. Then N2 is the refractive index of the medium 2. Then phi 2 is the refractive angle of the core 2. So this relationship gives the basic concept of total internal reflection. In order to have total internal reflection, we have to satisfy the two criteria. The first one, it should travel from a high refractive index medium to a low refractive index medium. The second condition is the angle of incidence should always be greater than the critical angle. If you satisfy these two conditions, then only the propagation path will be a total internal reflection in nature. Otherwise, it will be refracted out or it will be diffracted out. So, propagation of light through optical fiber faithfully follows the process called totally internal reflection, which is clearly depicted in the diagram. That's what we are happening in the optical communication mode. So with this, we can able to propagate the optical signal for long distance communication also. So we have to satisfy the condition that N1 should be greater than N2, and the angle of incidence, that is phi 1, should be greater than the phi c, that is critical angle. If you satisfy these two conditions, the optical waves can propagate for a very long distance. Then coming on to the manufacturing of the fiber optic types, the basic differences are there are two types of the one is called step index fiber, the other one is called graded index fiber. The step index fiber, the refractive index of the core is uniform throughout, as it is virtually like a rectangular in nature. If you see the refractive index profile, it will be rectangular in nature for step index fiber. If it is a graded index fiber, if you see the refractive index profile, it will be of parabolic in nature. These are the two primary types based on the manufacturing of optical fiber. In another mode classification, based on the propagation modes, we can classify the optical fiber in two ways. That is a single mode fiber, the other one is called multi-mode fiber. In single mode fiber, we can propagate only single wave at a time. In the multi-mode fiber, we can able to propagate more than one waves together. So these are the primary differences, one based on the manufacturing, one based on the mode of propagation. So single mode fiber is preferred for a small distance propagation, whereas it can be used for a laser as well as for launching power into the optical fiber is a difficult one. It supports a large bandwidth. Here intermodal dispersion is not at all there. It is particularly meant for a long distance communication. In the multi-mode optical fiber, the core radius is large. It can have more than hundreds of modes can be propagated. Generally, it will use LED as a source. It supports a very less bandwidth. Actually, intermodal dispersion will always be there. It is particularly meant for short distance communication. So basically, based on the optical fiber communication, there are commercially three types of optical fiber cable are prevalent. The first one is called monomode step index fiber. The second one is called multimode step index fiber. The third one is called multimode graded index fiber. You can see the refractive index profile. From that we can have the classification. In the monomode step index fiber, the core refractive index is rectangular in nature. In the multimode step index also, the core refractive index is rectangular in nature, but it is of broader in nature. If you see the multimode graded index fiber, the refractive index profile is parabolic in nature with broader in time. So these are the primary three things that we are using commercially for OFC. With that, I am going to wind up. So thanking you all for hearing my lecture. Thanking you one and all.